Welcome to our Interact lesson. And as many other Interact lessons, they are always dedicated to some Arctic or polar topics. And this one is no different. However, the title might be a little bit misleading in the beginning. So is it time to build an ark? But we're not going to focus on the Bible because it's a clear reference to the Bible story, but we're going to focus on the sea level rise, what happened in the past, most probably, what are the risks that we are facing now, and all of that, of course, in the context, especially our future possible events will be presented in the context of Arctic region. So I started with the Bible, and let's start big with the Great Deluge. And actually, it's the same as the Great Flood. What you see here is a quote from a Genesis book, and of course, it's written in the very biblical language, but more or less it tells us that there was a period when of a great flood, and what were the consequences? Of course, it's more poetically described. So the floodgates of the skies were opened. So basically there was a lot of heavy rainfall, and as a result, a great flood. So is it only a story? So stories of a very big, significant, ancient flood are present in the mythology of not only one, but hundreds of cultures. So for the Westerners, we might be most familiar with the story of Noah, which is told in the Old Testament, book of Genesis. But this great flood is also reported in folklore from cultures around the world, from Middle East to both Americas, India, China, Southern Asia, only to name the few. For example, there is a myth, flood myth, an ancient Babylonian myth, to be more precise, described in so-called Epic of Gilgamesh. And it tells us a very similar story, which is actually almost creepily similar, analogous to what Noah and to the story of Noah and his ark. So there was a man named Utnapishtim, and he built a ship to save his family and animals from floods brought on his city, and as usual, it's brought by the wrathful, revengeful god. And after 7 days, Utnapishtim and his family land safely on the top of the mountain. So we have very similar stories, and in general, the gods or God are sending a flood to wipe out humans. And there is one man chosen to survive. He builds a boat, brings animals, lands on the mountain. And so these floods are described as worldwide flood, which were covering even the highest mountains on the earth. So it seems like it was at least perceived as something that covered the whole earth. Did it cover the whole earth, or did it occur at all? And for the details, and the Bible says that the rains that caused this great flood lasted for 40 days, and the waters prevailed on the earth for 150 days, and the consequences were huge. Actually, this is a reconstruction, full-size interpretation of Noah's Ark, which could be seen. I'm not sure if it still can be seen in Dordrecht, Netherlands. I think it is still can be visited, because in the Bible, the description, the instructions how to construct this boat were very, very detailed. So we know exactly how long it was, what was the material, what was the shape, and so on. But what about the scientific evidence? Because these are some sort of myths, stories, maybe some records, historical records, more or less. Are they accurate, or are they even real? And the scientific community doesn't wholly doubt the possibility of a great flood, but we still don't have an answer to the questions of where exactly and when exactly it might have happened. Was it one big event? Of course, we're referring to a period where people were already living and even thriving sort of on our planet. So there are two dominant theories about this this type of event. So one scientific theory is suggesting that there was a flooding around the area that is now the Black Sea. And some other attributing very devastating floods, some other devastating floods that the scientists are attributing to a comet that struck the Earth. So the catastrophe would come from the skies. But still, so there would be a flood, but more local than one that covered the whole Earth, which makes sense, right? Because from the perspective of people who lived there, the whole world was destroyed or covered with water. So this is how they perceived the whole world. And so this is one theory from so the catastrophe coming from the skies and the catastrophic floods occurring. Then in the late 90s, two geologists from Columbia University proposed that a great flood still in the Middle East resulted from rising water levels at the end of the last ice age, so about 7,000 years ago. That's one of the theories and one of the time periods. And so at the time, the Black Sea was a freshwater lake, and the lands around it were simply thriving farmlands. And when the European glaciers started to melt or melted more intensely, the Mediterranean Sea overflowed, and it overflowed with a force like 200 times greater than the Niagara Falls. So it was converting, so the Mediterranean Sea would be converting the Black Sea from fresh to salt water, and it also would flood the area. So that would be the main two theories attributing the origins of flood either to the skies or the melting glaciers at the end of the Ice Age. Of course, from the people living there at that point in the Middle East, it would be a very catastrophic event, a disaster for their lives, for their households, for their farmlands. But it is also, some scientists also say that we owe something to the Great Flood. So what we owe is Great Britain. I mean, Great Britain becoming an island or islands. So Britain became separated from mainland Europe, which has, of course, very important geopolitical consequences. And it only happened after a catastrophic flood a long time ago, much more. It happened like 200,000 years ago. And some studies from the English Channel performed with sonars confirm that theory. So again, there was some sort of catastrophic event, perhaps an earthquake, a very strong earthquake, that caused the English Channel to be formed and the lake stream to breach at the Dover Strait. So the floods, the mega floods, the great deluges would also shape our our continents, our islands, how, and for now also how the geopolitical climate of today's Europe. So no matter what which theory is correct or more correct or would be dominant, maybe some other would appear and gain some evidence. What the Great Flood is a rise of the water levels. And in terms of a global catastrophe that we hear about, it's also refers to a sea rise level. But what's the difference between global and local sea level and sea rise as a consequence? So just as the surface of the Earth is not flat, the surface of the ocean bottom, is also not flat. So in other words, the sea surface, consequently, is not changing at the same rate globally. So there are lots of factors influencing these differences in pace in which the sea level rises or even drops, maybe in some regions. So, for example, there's erosion, some local or regional ocean currents that also influence how these levels are shaped. Also, variations in land height. Also, a very important factor that we tend to forget about, a so-called post-ice age rebound. What is post-ice age rebound? So in some areas, some say that everywhere, the land, the continents, are still rebounding from the very compressive weight of ice age glaciers. So remember, even though the ice age ended thousands of years ago, the last ice age is told to end a couple of thousand years ago. We are still, it's not a very long period of time in terms of geology. So the land is still rebounding. It's like relieving from not having to carry this massive weight of ice age glaciers. So the land was covered with ice for a very long time, and now it's, at least in some places, it's still sort of rebounding. So like moving up, speaking more simply. So these are the processes that influence and cause the fact that the global sea rise level is not the same everywhere and all the time. And what is the risk? What can happen and how significant this increase can be, at least in the future, in the 21st century? I mean, we're already much far into 21st century. So what can we expect in the upcoming years? So of course, these are only models and not truth set in stone. So models are not 100% accurate, and also they have different variants. So depending on some model variants, studies estimate this sea level rise, global sea level rise, between, on average, 30 centimeters to even 180 centimeters by the end of the century, by 2100. So this upper limit of these estimates is well above IPCC projections. So it's like very, very pessimistic. But these are different model variants, and as a consequence, with these different model variants, we can expect different parts of land to disappear underwater. But some parts of land are already disappearing. And of course, what is the islands, especially Pacific islands, are mostly in danger, at risk of disappearing. And it's a risk that's already happening, that's already materializing. So 5 tiny Pacific islands have already disappeared due to rising seas and also erosion, which is also a consequence of rising seas and climate change. So those missing islands were not inhabited by humans, at least. Those were not inhabited. There are tons of them that are inhabited. And they were not also huge, and ranging in size from 1 to 5 hectares. So they're not huge. But other islands, 6 other islands in the area, had large swaths, parts of land washed into the sea. And on 2 of those, entire villages were destroyed. People were forced to relocate. And this is very, very concerning, because it's not that they disappeared underwater, but because of rising sea level, there was a lot of land loss. And in this case, people lost their households as well. So for now, we can say, okay, it's far away. These are very exotic islands, like Nuatambu Island. Okay, it was a home to 25 families. They lost 11 houses since 2011, but oh well, they live on the island anyway. They are surrounded by water all the time. But there are other places that will or there might disappear with rising sea levels. Again, remember these dates are not exact dates. It's not a day, month, year, hour type situation, and also it depends on many other factors. But these are some areas of concern. So Maldives, a very popular but also very expensive holiday destination, might disappear by 2100. I already mentioned the 5 of the Solomon Islands already gone, but some of the places are much closer to us Westerners or people living in Europe, like Amsterdam, Hamburg, Venice. In North America, it's New Orleans, has 100, according to the estimates, has 100 more years to ahead. So these are the places that we know that are at least seem to be much closer, and make us think, well, what about us? Are our coastal areas in danger? So these are the risks, and these are the prognosis, the estimates for the future, again based on models, and models are not perfect, and what we put into the model is influences what we receive as an output. But there are some things that are non-debatable, like physical processes that are behind this phenomenon of sea level rise. And the first one can be a little bit surprising, because the first thing that comes to our minds when we think about climate change and rising sea levels is, okay, the ice is melting, but it's not that simple. The first factor is actually a very physical and natural process, which is expansion of seawater as it warms. Of course, it's a natural process, but rising temperature of seawater is not very natural, at least not at that pace. So as seawater warms, as any type of water warms, it expands. It just increases its volume. That's the comparison. What you see here is a representation of comparison of volume between the same amount of cold and hot water. So naturally, it expands. So it increases its volume, so it needs to rise. It's like we're in a bathtub, right? So it doesn't go anywhere. Of course, melting of land ice is another factor. Melting of the Greenland and Antarctic ice sheets, these are particularly concerning because these are large, huge ice masses, and the consequences of them melting would be really catastrophic. It wouldn't talk about few millimeters or 1 or 5 islands, non-habited islands disappearing. Another factor, maybe not that significant, is gravity. So, and again, it's also related to polar, not only Arctic, but polar regions. So, like the moon, ice sheets are huge masses and they have their own gravitational attraction. Every object has its gravitational attraction, but this is a very small object. It still has its own gravitational attraction. So we'd say the other objects would gravitate towards it, but it's so small that its attraction is minimal. But large ice sheets such as Greenland sea cap and Antarctic ice sheet, they are huge, so their gravitational attraction is significant. So as the Greenland ice sheet melts, loses ice, the gravity change reduces sea levels in Northwest Europe, which would be a good news, but melting of the West Antarctic ice sheet would have the positive effect. So these are, again, two examples on positive and negative, negative and positive feedback loops in climate change research area. Of course, there are also human activities which influence the sea level directly. We're draining wetlands, we're constructing huge dams, we're changing the use of land. So we're transforming our surroundings in a way that contributes to rising sea levels. How do we measure it? Because it cannot be measured simply standing on a beach with a ruler, right? So sea level is primarily measured using tide stations. That's one thing. And another thing is satellite altimeters. So two very developed types of equipment. So tide stations are situated around the globe and they tell us what is happening at the local level, but the sum of their measurements can give us an overview of what it looks like on the global level. So with the tide stations, the height of the water is measured along the coast, but relative to a specific point on land. That's why it's a point, it's local measurement. But satellite measurements provide us with the average level of the entire ocean. So the combination of these two, because the average level tells us, well, on average, it can rise 30 centimeters. But as we said in the beginning, it doesn't mean that it will happen at that the 30 centimeters is the sea level rise that we'll observe on the entire globe. No, it's not the case. It has local variations. So that's why we also need a network of tide stations measuring and comparing them on how they're changing over time on a more local level. So we mentioned that, yes, the land ice is melting. land ice and glaciers, but also Greenland and Antarctic are losing ice. They're melting. So what happens, what would happen if all the ice now on Earth would melt it? So these are, again, some estimations. 2010 is already behind us, but let's look at 2100. We see a very significant surge in water. But what would be the consequences? It's really hard to say. We only know that we only can try and predict some of them. So if the whole ice that is now on Earth melted, the sea levels would rise 7 meters, again, on average. That would mean not only the end of several Pacific island nations, large part of, for example, Bangladesh, Netherlands, parts of Eastern Britain, Florida, many coastal cities. But there are also lesser known and more hard to consequences that are more hard to predict, like blocking of the Gulf Stream. So a very important ocean current. So by melting water from the Greenland ice cap, if the whole or the large chunk of Greenland melted, it would block the Gulf Stream. And this would mean drastically lower temperatures in Western Europe, in the Arctic, and possibly a new ice age. So an interesting concept. So that would mean that the temperatures would drop and there would be more ice. So a negative feedback loop. But from our point of view, it would definitely not be beneficial for a lifestyle and for civilization that we have. And the question for you is, what about the icebergs and the sea ice? Several times I heard on the news that, oh, the icebergs are melting and this is a catastrophe. Icebergs are melting, this is a catastrophe, and this means that we will all be covered in water. What do you think? How accurate is that? You can try and write on chat. Any ideas? Should we fear the melting icebergs and sea ice? And why? I hope you're considering it right now. Okay, so first, definitely the sea ice, the Arctic sea ice is thinning. We often tend to concentrate on the surface that it covers, and which is also very, very important. But the thing is that it also is thinning. If you compare the depth of this sea ice layer between 1980 and here on the image in 2005, it's definitely thinning. It means it also is less durable and more prone to disappearing, to melting. But what about icebergs and sea ice as well? So the total amount of floating ice, that is floating ice, meaning icebergs, sea ice. That is all a floating ice, that something that is already in the water, right? That is turned into ocean water each year is equivalent to 1.5 million icebergs that are the size of the Titanic, which is a lot and which might sound very, very concerning. But melting sea ice, something that is melt or iceberg, cannot raise global sea level since the ice is already floating. Think of an ice cube which is melting in the glass full of water. Will the water pour over? Will the water pour over? No, because the ice was already in the water, and we'll get to that. So the Arctic Sea ice is thinning, and it is decreasing. That's the fact. But so remember that the Earth, the land contributes to global sea level rise. That means that if something was on the land, like a glacier or ice sheet, and it melts, and so it turns into water and contributes to sea level rise. But on the contrary, that's not the case for the ice that was already in the water. Why? Remember the Archimedes principle. So it's so-called physical law of buoyancy. And why is it Archimedes principle? Because it was discovered by the ancient Greek mathematician and inventor Archimedes. So the general rule is that any body that is submerged in a fluid in general, let's say in water, it's either completely submerged or partially submerged, is a subject to many forces. So it displaces an amount of water equal to its own volume, actually. So it cannot contribute while it's melting. It cannot contribute to additional sea level. But is it entirely true? I remember I hesitated a little bit that when I said that icebergs or sea ice melting turn into oceanic water. Well, they do, but the water that this ice was made from this ice is made from fresh water, so it turns into fresh water, and the oceanic water is of course salty water. So there is a difference in the density, right? The fresh water is less dense than the oceanic water that was surrounding the iceberg. So when the icebergs melt, the resulting ocean water, which is fresh, not salty, has a little bit greater volume. A little bit. It's not equal to what would happen if the same chunk of ice melted on the land. It's like about 2.6% greater in volume. That's the volume of the water that the iceberg already displaced, like Archimedes said. So actually, it's not entirely true that melting icebergs do not contribute to sea level rise. They do, they can, but it's not one-to-one effect, right? It's just a small effect due to differences in density. So it is estimated that it gives us additional 0.3 millimeters per year. Not a lot in comparison with other factors. I mentioned that some people inhabiting those islands in the Pacific who were forced to leave their homes. They lost the whole villages were destroyed, even though they were not actually covered with water, right? Because sea level rise is not only losing Venice or Hamburg or New Orleans, even though that is something not acceptable, not only from the point of view of people living there, but it also has a lot of negative consequences, such as contamination of drinking water and destruction of farmland. Remember, it's a salty water, and most plants are not, especially most crops, are not used to salty water, so they will not thrive under such conditions. For the same reasons, it can endanger wildlife populations because their ecological range of ecological tolerance does not accept salty water or so much humidity, and as a consequence, as usual, it all hurts the economy. So salt water is unsafe to drink. I mean, straight from the ocean. There are technologies, but they are very energy consuming that can turn salty water into drinking water, but normally salt water is unsafe to drink. It is possible to remove the salt from water, but it is a very complicated process. So some communities are already investing in some climate change adaptation, because climate change adaptation is something that we often tend to forget about. At least that's what I've observed lately. We focus on preventing the changes, which is great, but what if some things are impossible to prevent, or at least we should be prepared for the scenario where and when we'll have to adapt to some point. What if it doesn't work? What if it doesn't work fast enough? What if some limitations do not have the effect because the whole system is more complicated than we can imagine? So some communities do remember that we need to adapt, and they're already investing in some sort of adaptation in terms of construction, building construction, some protection from this rising sea level. Some even invest in, I think it's in California, that they invest in plants that desalinate seawater, right? So it's starting to be more and more common, but it's very, very, very costly, very, very expensive. But it's also a way to adapt and to react to climate change and to sea level rise that to some point we will probably face in our near future. So thank you. That's about it. That's all I had to say.